In this recording, we're going to look at using equilibrium, and we're going to solve a problem, and we are going to solve a problem with a tool called an ICE chart. It is ICE, and it's a mnemonic for initial initial change in equilibrium. Okay, so here's a sample problem, and we're going to use ICE. Now remember, ICE or ICE charts, and I is the initial situation, the C is the change, and the E is equilibrium. Now, some people will not choose to use ICE charts because they will mentally adjust the values in their head using the math, but I really recommend following the ICE charts because there are going to be some reactions that are a little more complex, and this is a valuable tool, and this is how they teach equilibrium problems in college. So if you read the problem here, it says the mixture of 0.05 moles of H2 and 0.01 moles of I2 is placed into a 5-liter container at 448 degrees Celsius. The concentration of HI is 0.00187 molar at equilibrium, and they want to know what the K value is. So they've given us multiple different pieces of information here. They've given us some initial values that we've mixed, and then what our concentration is later on. So they gave us a balanced equation, H2 plus I2 makes 2HI, and it's at equilibrium. The first step you need to do is you need to have the values for the substances in a usable format. So molarity, we will be using molarity almost exclusively. There is times that you're going to use pressure, but concentration and molarity is key here. So they gave us H2 and I2 initially, but they did not give us those values in molarity. So for our H2, we're going to take our 0.005 moles, and we're going to divide it by our 5-liter container, and that will give us a value of 0.001 molar. And we'll do the same for our I2, and we have 0.01 moles and our 5-liter container, and so our molarity here is 0.002 molar. You have to have it in molarity. It is the only way you're going to get the right answer. All right, so this is an ICE chart. We have our initial value, our change value, and our equilibrium value for all of the substances, for H2, I2, and 2HI. So you can see that we have plugged in our 0.001 molar and our 0.002 molar that we just calculated. In the problem, they told us that we had 0.01 molar H2 and 0.002 molar I2 to start. They did not mention HI. So anytime they don't mention it, we get to make an assumption that there is 0 in the initial container. So we're starting off with just the two reactants. And so what we're going to do is we are going to take the value that they gave us for the HI at equilibrium. And they told us that we have 0.00187 molar HI at equilibrium. We know that we are going to change from 0 to 0.00187 in the course of this reaction. So in order for that to happen, we have to have a change value of 0.00187. Somewhere we have to form the full amount. So we have made two HIs, and our value is 0.00187 for the change. Now in order to form these, this side would be positive. We're forming them. So that makes this side negative. And we also need to consider the fact that every time we make two of these, we have taken away one of each one of these. So we have to deal with the stoichiometry. So our change value on the product side is twice that of our change value on the reactant side. So we're going to divide our 0.00187 in half, and we're going to have 0.000935 for both of these because they have the same coefficient. Okay, so we're just using the coefficients to find a new ratio. We know that we have formed 0.00187 HI in the course of the reaction, and we have reduced our starting values by the 0.000937. So all you do now is you will subtract your initial value minus your change, and so you are left with 0.000, one more 0.065. And here we have 0.001,065. Now these are very small concentrations. We're working on a very small scale, but these are the correct values. So in order to find K, we take the products minus the reactants. So our first product is 0.00187, and we know that that is squared. And we are going to divide by the reactants. So 0.00065 and the 0.001,065. And when you do the math and the multiplication, you get a K value of 50.5. Now 50.5 is kind of neutral. It doesn't really favor the reactants or the products. It is slightly favoring the products. So this reaction would be leaning towards the equilibrium, and that makes sense because I'm sorry, not the equilibrium. We're favoring the products. Because we started with reactants, and right now we are building up our products.